So it's day 2, workshop Introduction to Unix command line. So this is what we covered in day 1. So let me just briefly remind you. So we started with looking at the current directory. When we looked how we will change the directories, we saw the command ls, which allows you to look on the content from the current directory, meaning you will list the files and directories which are there. So we understood the difference between the copying, moving, removing, right? And then also we saw how we would create the links, right? The soft links to files. In the case we don't need to modify the files, but instead we want to have them handy in the current directory. And yeah, so also we saw how we will transfer the file, right? From the cluster to the laptop and from laptop to the cluster. Okay, so let's practice how we'll transfer the files from the laptop to the cluster, and then this is a good opportunity. We need to have, I created the directory on the web page called W files, like working files, and we will need to first of all go to the web page of the workshop, get this zip file, w1 files.zip, download on your laptop, and then we'll need to transfer that file to the Hoffman 2 cluster, right? So that's the plan. So for the Mac, you will be using the terminal SCP. For the Windows, please use the WinSCP tool, the software tool, right? Which you installed by drag and dropping the file back and forth. Okay, so let me just remind you. So we will need to do this kind of operation, right? So we have a local files which we want to transfer to the cluster. So you do SCP, the name of the file, your username, hoffman2.idre.ucla.edu, and the path where you want the files to be placed. Okay. So this is exactly the command we need, where we say SCP, the name of the file. In this case, this is archive, zip, and your username, hoffman2.idre.ucla.edu. And then here I just use the notation where I just say the tilde. So basically, this will mean that I want to copy the files to my home directory, right? So tilde stands for your home directory. I don't want to type the whole thing there, just to avoid any typos and things, but then later on I can copy from the home directory to any location I want, right? So how about that? Okay, so let's try to do it. So for that, first of all, we need to get the file. So please open the workshop. So it's QCB CLA. So this is here. And scroll down. So those are the slides. Put it somewhere. Can you see it? V1. Okay, that's the link. Class materials. Just click the link and download somewhere on your laptop. So for the Mac, open the terminal. For the Windows, open the WinSCP program. So just open the terminal. That's the idea, that when we are transferring the file, we always will do it from the local session. So all you need to do, just open the terminal, don't connect to the cluster. Okay, so I'm on my laptop. It says MacBook Air, so right, so it's kind of clear. Okay, so now let's go to the directory where the file, that zip file, is located. So you can check where you are right now, right here. Usually I do CD just to be sure, and then I go to downloads, because this is where I expect the file is. So let me see. So I think it's called V1. Okay, so that's the file. Okay, you can check how large it is if you're curious. Okay, so it's 29 kilobytes, right? Okay. So we do have the file, right? So please, so this is for Mac. For Windows, again, we need to use WinSCP. Okay, so because I want the file to be located locally in the same directory where I am, and that's the case for me. So I'm located in downloads, and the file is there as well. Okay, so now let's type exactly the command I have on the slides. I make it smaller. Okay, no, I need to. Okay, so we do scp name of the file. Again, you can use the tab, please do so. State your username, name of the cluster, .idre.ucla.edu, and then we say tilde, which stands for the home directory. Right? Okay, so if everything is fine, you did everything right, it will ask you for the password, and okay, wrong. Okay, and then you should see the progress. Okay, so let me make sure that everybody got the file. This is kind of crucial to have it, otherwise you can not do exercises during the workshop, and then we'll start from there. Looks like everybody got the file, which is great. So I guess one small notation, kind of note, which I don't have it here. So sometimes for some laptops, if you download the file, and then it might unzip it for you. So if that's the case, do -R here. So which will stand to copy the directory. The same way as you do cp for the directory, put -R. The same way, if that is not the zip file but the directory, put -R right here. So that's the only difference. Okay. I'm sorry? Yeah, so sometimes when you download the file from the web, your configuration of your laptop will unzip it for you. So if you don't see the zip but you see the directory, to copy the directory, you always put -R, like this, -R.
And that will unzip the file?
No, that will not, assuming the file is already unzipped. Because some laptops do it automatically. So you don't see the zip, you see the directory.
Yeah.
So the short message, if you want to copy the directory, not the file, you always use -R. Just the same way for the cp. If you copy the directory, you're using -R. Okay. Okay, so any questions here? So I think everybody got the file, which is great. So we can move on. Okay, so for the Windows, looks like it works as well, right? So you have WinSCP, which works, I think, even simpler. You just drag and drop the files. Okay, so one thing before we'll get into the core of the day 2. So I want you to be able. This is for Mac. I want you to be able to connect to the cluster using the not typing SSH, Hoffman2, stuff like, I mean, your username Hoffman2, but instead I want you to just type Hoffman2 and get it on the cluster. So for the Windows, please use the session from the PuTTY, right? You have the session, so you're saving your time. So for the Mac, so this is, again, only for the Mac. So what we want to do, we want to do the same thing, we do with the alias when we did cp-i or move-i, right? So, so what will happen? So instead of typing this long line to connect to the cluster, all you need to type will be this Hoffman2. Okay, so if you want to do it, just follow me. So on your local session, don't connect to the cluster yet. On your local session, do cd, make sure you're in the home directory. Then do the same thing as you did on the cluster yesterday. vi.bash_profile. If the file does not exist, which is the most probable, it will be created for you. And then just add one line. Just don't make it type. Try not to make the typos. Alias, Hoffman2, or any other words you want to be typing to connect to the cluster. Equal, single quotes, SSH, your username, add hoffman2.idre.ucla.edu. And what you need to do, you need to restart the session. So basically click tab, Command T, to open the new tab. Okay, so let's do it together. So local session, right, here. So you do cd to make sure that you're locally. Then you do vi dot bash underscore profile. So probably the file does not exist for you. It will be created. Press enter. You should not see this message. This is just because I didn't close the file properly. If that's the case for you, just press enter many times. You will get. But then you should see empty file. This is what I guess you do. Okay, as you see the empty file, press I and type exactly this line, which is right here. I do have it already. This is how it will look like, right? Okay. I do have many aliases. You should have the one, I guess. Okay, so if you're done with the typing, as usually to close the file, you do escape, right? And then shift, semicolon, gives the column WQ, right? So this way you will close the file and press enter. Okay, it doesn't work for me for a reason that I didn't close it properly. So if that's the case for you, add the exclamation sign. Again, I don't believe that's the case for you, just in case for information. You should do something like that, right? WQ. For me, I can't, I should force it. Okay, so you save the file, and that line, exactly this one, is there in the file. So now let's restart the session, and then what I mean, just do Command T, open the new tab. Okay, so as you open the new tab, right now type Hoffman 2, just. And then again, you don't even need to type the full thing, just type Hoff and then press tab. It will be auto-completed for you. So pretty fast. Okay, press enter, type your password. So you should be on the cluster if everything works. So let's go ahead. Okay, so I want to discuss the differences between the relative and absolute path, and then we saw a little bit of absolute path where I told you that you need all the time use the absolute path when you create the symbolic link, right? ln minus s, all the time using the absolute path. Okay, so let me give you the intuition behind. So if you think about the address, and then all of us living in Los Angeles, so probably when we change the address, we will say the street number, the house, but we will never apartment. We will never say the city, assuming that we are all in the same city, right? So that will be relative, because if you talk somebody from New York and then you say the address, he will be confused because he will be trying to find that street in New York. So this is relative, right? Relative to the city, or relative to the directory you're located in, or relative to you, because you assume my home directory is this one, and then you use the tilde, right? So it's all relative. So as the absolute path, that will be an example where you give exactly the street you're living, and the name of the city, the state, the zip code, and so on, right? So you give the absolute thing. Okay, so the same thing, like that will be the absolute path to the, this will be the absolute path to the file which is located in the test directory, in your home directory. And that's the name of the file, right? So this is absolute, nothing to add at all. Okay, and this will be the relative. You're assuming that the file is located one level up from the directory you are currently is allocated. Okay, that will work only in the case if you're here, right? If you're here, the directory is one level up from this one. Okay, for example. Actually, when we do less and the name of the file, we just use less, right? And then we just say it in the file name without dot slash. That is also already kind of the relative path. Kind of putting nothing in front of the file, you assume that the file is in your current directory. That's an assumption, because this is what probably we're trying. Then you do SCP of the file, and the file is not in your current directory, that will not work. So the kind of the formal way, which you don't need to use, just I want you to be aware of, that this is kind of the shortcut to refer to your current directory, right? It says /, but you can avoid it, skip it, and just go as usually we do, the name of the file. So when we do ls-l to /, saying one level up, I want to list all the files and directories which are located one level up from the directory where I am right now. So this is the relative path, right? The same as the tilde. So it assumes that your home directory. And then if you exchange with somebody, that will not work because somebody else will have a different home directory. Okay, so I wanted just to emphasize the difference between the relative and absolute path. Okay, so any questions about that? Okay, so let's talk about something else, which will be the file permissions. And we talked it a little bit when we were discussing when to use the copy, or if somebody shares the files for you. So the idea is like there is very many people on the cluster, so everybody need to live together. So there is 7 permission levels just to make your life safe, so nobody else can access your files, to delete them, and so on. So I guess if you think about the cluster, so there is 3 kinds of people on the cluster. You as a user, your friends, which usually your group, or the people under the person who approves your account, and the rest of the world. As it comes to the permission levels for the files and directories, there is 3 permission levels as well, where the first one is R, stands for read only, meaning that you can access the file, but you can't modify it. W stands for write, so you have the permission to remove the file, to change the file, and so on. And X, when X refers to a file, it stands for being able to execute the file. So usually that refers to the scripts. So you have a program you want to run, so to be able to do so, you need to grant the permission to be able to execute it. So interestingly, in the UNIX, even for yourself, by default, you don't have a permission to execute the file. And I guess it's done for security reasons, just so you will not accidentally run something. Kind of, you need to grant the permission for yourself to be able to do it and then run the program. So this is how it's done. So when X stands for directory, that will mean that you are able to see the content of that directory. Okay, so 3 kind of people, 3 kind of permission level. So if you do ls-l in your directory, this is the long list you would expect to see. And then if you look at the first column, this is exactly where those permissions are. And then this is how they will look like. So the very first letter, so either D or slash, I'm sorry. So that will be the type, right? So that is the type. So it's either directory or the file. And usually it's also highlighted by the color, so you can look at it here or just judge it by the color, which I guess might be easier. Then you do have, it should be shifted a little bit, so it should be this exactly R, W, and the dash, right? So so you do have the permission to write for yourself, to read, to write, and then you don't have the permission to execute. So as it comes to your group, that will be only writing permission. Only reading permission, and the same for the rest of the world. Okay, so to change the permission, you use the ch mode, which stands to change mode, and there is one parameter where you say to whom you want to change the mode, for you as a user, for the group, or for others, for the rest of the world. Or you want all of those 3 groups simultaneously. Then you say A, which stands for all. Then you say plus or minus, meaning granting permission or taking it back. And then permission level, which will be R, W, or X. and the files or the file names. I'm sorry, one file or many files. Okay, so let's do ls-l in your test directory. If we do so, that's what we expect to see. That's a default, right? So you have the permission for every file to be able to read and write, but not execute. So what about we want to grant the permission to be able to modify the file for your group? And the file we want to do it will be large.txt. So to do that, you just say G, your group, plus grant the permission, W stands for writing, and the file name. And then you should be able to notice the difference if you run this command. So W will be here, right, as it was not before, right? So your group will have a permission to modify that file. Okay, so why don't we try and see how it works? Yeah, maybe I use it. How did you get your account? Do you have it long ago or like just recently? Yeah, maybe your configurations are different. I guess it's not no X for me. It's kind of interesting why your configurations are different. I don't know. I never saw. Yeah, I guess configuration may be different. So if you can run, we'll see in the day 3. So probably you can run any program you create. Okay. Okay, so let's try. So we need to go to the test directory, right? And then we do ls-l, and then there is a file large.txt, and for the group you don't have writing permission right here. Okay, so we want to grant it. chmod g plus w name of the file. Okay. Press enter. Okay. So G stands for your group. Plus stands to grant the permission. Somewhere here. Okay, so it's here. Group plus and then permission level. Okay, so and then if you do ls-l, then you should see W right here. Right, meaning your group will have a possibility to edit your file. So if you change your mind, you don't want them to have this possibility, you just say minus right here. Basically saying that you want that permission back. So if you do so, and do ls-l again, you should not see W here anymore, right? Okay, so this is how it works. So any questions? Okay, so if no questions, let's go ahead. And then I guess we're starting my favorite part, where we're talking about redirections and the pipelines. Okay, so redirection. So when we run the program like ls, or let's better say when we run the tool, right, like ls, or any, which we want to list the files in the current directory, we see the output on the screen, right? We run ls, and we see the files on the screen printed for us. So what about we want to save the output of the program into the file and use it later? Okay, so we run the program. We say we use this sign, which will stand for redirection. So we'll redirect the output of the program A to a file which we'll call the file.txt. If the file does not exist for you, it will be created. So here there is a trick where if the file does have the content, so there is something in that file, the file does exist, it will be overwritten. Right, so always be careful with this command, because the alternative will be this one, where you append to the end of the file, right? So I guess that's the choice you need to make every time, right? Do you need the previous content in this file? If you do, use this, just append to the end. If you want to override the file, use this redirection sign. And if you want to provide the input for the program, you can use kind of opposite sign to redirection. You will provide the input for the from the file to the program. Okay, so any questions? Okay, we'll see some examples, I guess will be more clear. Okay, I have some examples. So when we do, but we didn't cover W, so let's keep this example because we didn't look at the WC minus L yet. So I guess like, yeah, let's cover WC first and then we'll come back to this example, okay? How do you tell it where it is? I mean, you assume the file is in your current directory? So every time we talk, we assume the file is in your current directory. If it does exist, that will be overwritten. If it does not exist, that will be created. Yeah, unless you specify a path to the file, it assumes, if you don't specify anything like here, we kind of assume by not specifying the path that the file is located in your current directory. That's kind of the assumption we will be using all the time. Okay, so let's keep this example, we'll come back to it. Okay, the pipeline. So I guess that is my favorite part. So by using the pipelines, we will be able to answer the new question using the old knowledge. This is kind of the idea. It will be combining the things. So the things we learned will be combining, and suddenly we'll be able to answer the question you might think you don't know the answer to. Okay, so how it will work? So we say program A, the pipe, program B. And what will happen that the output from the program A will serve as the input for the program B, and so on, as many pipes you put. Okay, so the alternative will be this. Run program A, save the output from program A somewhere to a temporary file. Run program B, provide the input from a file to the program B, and so on. So it's exactly equivalent solution, besides that you should run like kind of twice, you should waste the storage by using these temporary files, and so on. So again, you remember we are trying to achieve the skills where we can run the single command, maybe the long one, but the single command, and get the answer by a single command. Not getting distracted, running one command, second command. Imagine you have 10 pipes, right? 10 pipelines. Pipeline composed of 10 steps. Then you need to have 10 temporary files, 10 times, and so on. So it's really nice thing. It's like you have a single line, which is really powerful. Okay, we'll see examples, should become more clear. Before that, let's see what is WC, and then we'll be ready to see some examples. Okay, so WC stands for counting, so we'll be word counting, I guess it stands for. So we'll be counting things in the file. So if you run WC and the file name, it will tell you everything. It will tell you number of characters, number of words, and number of lines. Just like this. So sometimes all you care about, just number of lines. And for me, that is the most common thing I use. I got the file, this is the first thing I do. I check how many lines there is in the file. I kind of know, and then I see, oh, probably it was transferred properly. Oh, like just first idea, is it large? What's going on with the file? So if you want just the number of lines, -L, that's your choice. Okay, so let's run WC for any file. So if I would say we don't have the log file, so what about we run WC for large.txt? So, but it will be exactly the same. So we do WC, name of the file. We'll give you this long statistics. So if you want just the number of lines, you run WC -L and the file name. It will tell you the number of lines in a particular file. Okay, so can somebody tell me what this command is doing? So you know all the commands. I mean, you know what is ls, right? It lists all the files and directory in your current directory. You know what this WC does? It counts the number of lines in the file. So if you combine both, what it will do? What is this command stands for? Yeah, exactly. Number of files and directories. Right? So how does it work? You do ls. The output of ls, this is just the list of the files and directories, right? Just the list. And then that list comes here, And the WC minus L will count the lines, which will basically be files and directories. Okay, so this was my idea that if I ask you kind of beforehand how to count the number of lines directories, probably will tell me, I don't know, we didn't cover it yet. But suddenly, by combining two things, you are able to answer that question, right? So there is no new piece here, but just combination, which is brings the power. Okay, so let's try it. Okay, so we do WC, let's do large. Okay, so it tells us what? I already forgot. So it tells us number of lines, number of words, and characters. So number of lines, number of words, number of characters. In our case, number of lines and number of words are the same, just because on every line we have a single word, right? A single digit. Okay, not the digit, this is the number, right? The number is per line. Okay, so if you want just the number of lines, do minus L, and you will get the number of lines. So if you are curious to know how many files and directories are in the current directory, so do this, and you will get 4. That sounds right, right? 1, 2, 3, 4. Okay, so it works. So any questions here?
You're using the WC for like text file?
Yeah, so originally WC is designed for the text file, right? So this is how you would run it. So, but then if you're interested in, so if you're interested in the pipeline, so this is how it works.
Yeah, because since I wasn't logged in last class, I only have my zip file.
Okay, so you get one?
Yeah, so when I do the WC command, it gives me lines and characters
But
from a zip file.
it's all right, but it's not so, I think zip file is not, I think might mislead you. So if you're counting, because zip file is compressed file, so I guess the number of lines in that file will be, whatever, it will give you some not accurate number. Because just that's the zip.
It gives me a number of lines, but I'm like, what
Right.
lines?
Right. Yeah, it's
Okay.
cool. Yeah. Okay, any other questions? Okay, so I guess let's come back to that example with redirection, since we know how to do, right? So we'll be talking a little bit about the redirection. So I just want to give you the example. So since we know what is WC stands for, so we do WC minus L as we did before, and we saw the output on the screen, right? This is what we saw. But we want to save the output of this command to a file. And we do so. We do WC minus L, file name, and then redirect to a file, which does not exist but will be created for us. Okay. Then, as a next step, you do ls and redirect the output of ls to the same file. So what will happen to the file? It will be overwritten, right? Because at this stage, here, the file already exists. So whatever was there before will be deleted and the new content will be placed. If you run the second line, another command, where you want to list 10 first line from that file, and then you want to append to the file. So the content of that file will be preserved, and these 10 lines will be added to the end of the file. Okay, let's try those, and then we'll see what's going on with the file at every stage of this. Okay, so the first command is wc minus l large.txt. So we run it, but let's run again. So this is what we see on the screen. We don't want to see it on the screen, we want to save it to a file. The file does not exist, but it will, and then it will be created for us, right? Okay, so we want to redirect the output of the command to a file which we'll call f_ls.txt. Let's do it. Do you want to see what is in the file? Do less. So inside the file we have exactly that line. Okay, expectable. Right? So what about we do ls, and then we got the list. What about we want to save the list of all the files? We want to save it to a file, the list itself. We just say the file. So now, what is in the file? In the file, we have exactly that line saying, what is that? Exactly this line, right? Is the moment in the file is here. We will overwrite it. That line will be gone, then the new content will be placed. Okay. Let's check what is inside the file. So inside the files are the result of ls command. And then the previous content was deleted. So what about we want to preserve the previous content? So we run the command head large.txt, which will display first 10 lines from the file, and then we'll append to that file. Just like this. So this way, what was before in the file will be preserved, and new things will be added to the end. Okay, so do you want to try less? So you see the first part, which was the result of ls, and then right here, you start seeing the result of head. Okay, so both things are there. So the point here that it's really up to you. Do you want to preserve the output, or and then do you want to preserve and append to the end of the file, or you want to override the file? Sometimes you need to override the file, which is fine. Just be aware of that and be careful. So any questions? Okay, so we covered kind of cat, and we know the cat command stands for like display the whole file onto the screen. But actually cat can do more, it can concatenate the files. So given many files, you want to put them in the order, and so to concatenate, so you just use the cat and list the files in the order you want them to be concatenated. So for example here, you do cat file1 large.txt, file2, and then concatenate it to a new file. Also, you can count how many lines there are in both files. You do concatenate first, and then pipe and count how many lines. So 21 lines in both files. Okay, let's try it. So you do cat large. Do you have any other file? Maybe let's go to directory new, see what is there, pick up any file. Don't forget to use the tab, highly recommended. Okay, all text. Okay, so we'll concatenate the file large.txt, which is located in the current directory, and the file which is located in the new directory new, and that's the file name, test2.txt. So, and then we'll dump both files into the file all.txt. Okay, we do so, and let's check what is in all.txt. Okay, so in all.txt should be both files. Okay, looks right, I guess. Okay, so if you want just to count number of lines in both files, you put the pipe and you do wc-l. So this way you will count how many lines there are in both files. And there are 30 lines, which sounds right. I guess I have 29 lines in my large.txt and 1 line in the test2.txt. Okay, so any questions here? Okay, so let's go ahead. Okay, so this is kind of side note, just to tell you how, if you want to find something, if you want to find the file which is called test.txt into directory new, you run exactly this command, and then you should be able to find it. And then if you don't remember the directory where the file is located, so search in your home directory. Your file should be there, right, somewhere. Okay, so that's for your reference. Okay, so we are switching to the part which is the most, which requires the most kind of programming. So we'll try to avoid it as much as possible, but we still need a few conceptions to cover. So in order you will be able kind of to understand. Okay, so it might be confusing in the beginning, but I guess as we move on, it will be better and better. Okay, so we'll be talking about the grep. The grep is the tool which is used to search through the file. So for example, you have a large file, maybe a million of lines, and you want to find all the lines which contain the string apple or the word apple, right? So this is for what you will use the grep. And there is a couple of options for the grep. For example, there is -v right here, where it will stand for, so you want to find all the lines that do not contain the word apple. Okay, use -v. Also, maybe you want to know the line number, right? Not the line, not only the line itself where the apple occurs, but as well as the line, the line number. Okay, use -n. If you want just to know how many lines do contain the word apple, just use -c. Also, you don't necessarily need to search for a single file. You can search for many files. If you do so, maybe all you need to know is the question is, does the word apple occurs at least one in that particular file? So then you use -l option, and then that will tell you only the file names where the word apple occurs. Also, sometimes you don't need case-sensitive search, right? So you might expect somebody did a typo in your last name, right? Did it with the lowercase. So you want to make it case-insensitive. So use -i option. Yeah, you just combine two, so you can always combine. So I guess it will be -vn, and then it should work.
Like you like in one thing?
Yeah, you do minus. I mean this -vn. Yeah, that should work. Control. Okay, so any other questions? Okay, so let's try. So we do have the file which is large.txt. So what about we do grep? The thing we are searching will be digit 1. So I recommend all the time to put all the time in the double quotes. So the truth is that sometimes you need double quotes, sometimes you don't. I don't want to go to the discussion. I would rather tell you that all the time put the double quotes and you will be safe. Okay, so we look for the digit 1, for the string 1, in the file large.txt. So if we run this grep, this is as expected, we'll see the lines where 1 occurs, right? So sounds right. So if we want the line number as well, we use -n. That's how it will work. So here, just because the file is kind of artificial, right? So the kind of the line number will coincide with the line itself, but it shouldn't be the case in general. Okay, so -c will count how many lines do contain the string or the digit 1. And then there is 15 lines. I guess it should be larger a little bit for us. Okay, so can you think of the alternative way to do it? So if you don't know -c option, or you forgot, right? All you know, you can grab the lines which contain the digit 1. So what will be the alternative way to do it without -c? So any ideas? Yeah, exactly. You put the pipe wc -l. Alright, so that's the idea. So we'll have all the time alternative way to do things. You don't necessarily, the class, I guess, is not about really memorizing every single command or every single option. It's not about that. It's about you kind of understand which command to use and find the way around, because it could be multiple solutions to a single problem all the time. If you don't remember the option, I'm sure you will find the way around, like here. Okay, so if you want to know only the file names, right, use -l. We look for the two files, large.txt and the test.txt. And then we want to list only the file name where the 1 occurs. And then will be this large.txt. So if we don't use the -l option, this is how the output will look like. it will tell you the file name and the line where a digit 1 occurs. Okay. So any questions before we try? Okay, so let's try it one by one, see how it works.
I have a question.
Sure.
And if you want to look for more than one thing?
I mean, here you should be always like kind of careful. I mean, what exactly you mean? You want to look for 1 and 2, for example?
Yeah.
But then think like both or at least 1. Because if you look for at least 1, that you don't need the second one. If the string contains 1, it will be kind of displayed already, right? So if you're looking simultaneously for both, so you need to know, do you want them to be like this, adjacent, or you want something in between, and then like this?
Yeah,
So yeah. So this kind of stuff will be looking for the regular expression that will help you, and then you will kind of find the answer there. But if you want something like this, you just specify this kind of string, and then you look for it. But this gets more complicated. So regular expressions. Okay, so let's try one by one. Sure. So try Control C or Control X. Let's try. I don't remember that. Something like Control Z, but not Control Z. Yeah. Control C. Okay, so if you forgot to close single quote or something like that, so you kind of expect the type from you, and then you got stuck. So Control C is your friend.
That's like abort pretty much?
Huh?
That's like abort?
Yeah, so like, yeah, but abort in a specific way. Because usually abort is like Control Z. But in this case, somehow you need Control C because it's waiting from you something. You know, just close this quote. Okay, so let's try by one. If there is no questions. Okay, so first one through the file, right? So we look for digit 1 to occur in the file large.txt. Okay, so this is what we see. I guess it's expectable, right? This is where the 1 occurs. So if we do -n, so for me it's different just because I guess I did the type. I mean, I skipped some digit, like 10 or 9. That's why the line number is different from the string. The line number is different from the line itself. But if you did in the order, then it should be the same for you. So -c tells you how many. Okay, this many. As well, if you don't remember -c, use WC, just like this, right? WC. Okay, the same answer. So if you're looking for many, through a single file, but through a couple of files, and then all you care about is to know the file name where the string you're looking for occurs at least once, then you say -l. And here you can provide as many files as you want, just put the space between them. So file name, space, file name, space, file name, and so on, as many as you want. Okay? So it shows me only the file large.txt, means that the string 1 only occurs in the file large.txt, but does not occur in the file test2.txt. Okay. And then if we remove -l, it kind of will be long output, where it will tell me the file name and the string, and the line itself. Okay, so any questions here? Okay, so let's go ahead. Okay, so I think we'll take the break in 10 minutes, but before the break, let me give you the motivation example. So we do have the HD19 file in that zip file, which we'll unzip in a second. So this is a toy example of the real gene annotations, where you have zones, the UTR and so on. And so here, the format is that as the first column, this is the chromosome number, chromosome name. And what we want to do, we want to extract the entries, the lines, which corresponds to the chromosome 2. And we know kind of how to do it, right? We do grep chromosome 2 and that file name. And then we save it to a separate file, which we call chromosome2.txt. Okay. And then, okay, so let's do it. And then you will see, we'll check if it really works as expected. Okay, so first of all, we need to get the file, and the file should be located in your home directory. So please move it to your test directory. So the way you do it, you do move the file right here. If you have a directory, it will be the same, because move it's the same for the directory. Okay, for those of you who has the file which is unzipped, please unzip it using unzip name of the file, just like this. This file. Right? So that's the command to unzip the file if it's not yet unzipped. Okay? So and then as a result you got the directory. So please go to the directory. Okay. Right, so you unzip the file first. First of all, you need to copy, you need to move the file to the test directory from your home directory. Right? Because this is where you did copy your file. This is the move. Right. So being, I'm sorry, yeah, but I better, okay, so let me show you. So being in the test directory, where you are right now, right? In the test directory, you want to move the zip file right here to your test directory, to the current directory. This is what it stands for, current directory. Yes, you will move it right in the current directory, in the test directory. Okay, so you did move. The next command you run will be unzip. This one. So given the file being located in your test directory, you want to unzip it if it's not unzipped yet. So you do unzip and name. So you do run this command. I don't know, did you explore it? So okay, you create a new file. So the first thing again, I check number of lines. WC minus L, the file name. Okay, 2000 lines, fine. Then you do head, for example, chromosome 2. Okay, the head looks fine, chromosome 2 is here. Looks good so far to me. What about we do tail? You can do tail -1, it's not kind of crucial. I mean, it just gives you an idea about the file, right? So you're trying to understand what's going on. Let's do minus N1. Okay, so here, if you look carefully, you might notice a problem, right? Why do we see chromosome 1? Is it something we expect? Right? We were thinking that we'll get only chromosome 2. But if you look carefully, what is 21? So we kind of grab chromosome 2, but chromosome 2 is here, right? That's the chromosome 2. So we can't distinguish at the moment between chromosome 2 and chromosome 21, right? Because chromosome 2 is the string, chromosome 2 is inside the chromosome 21, right? So we need to know a little bit more to be able to distinguish those things, right? Okay, so that was the motivation. And I guess, yeah, let's take a break. Let's take 10 minutes break. Okay, so let's continue. Okay, so we'll be talking about the regular expressions, and I guess the way you can view it, that will be a string which simultaneously describes several sequences. Not like apple and apple, but maybe saying a word composed of 6 characters, which starts with A and ends with A or ends with E, right? So it can be not a single kind of match. We are targeting broader space. Okay. So let's start with the very simple examples, and as we move on, we'll see more complex regular expression. So given a sentence like UNIX tools rocks, we're trying to find the regular expression, which is exactly this string. And then that's a match, right? Or like this kind of sentence, this will be a match. And you cannot find the match here. Okay, that was simple. So it can be not necessarily a single match, but maybe several ones. So giving a line or a sentence, that's a match. And this is a match. Okay. So let's see a real regular expression, which is a dot. And dot means any character. So we're looking for the string composed of 3 characters. The first character is O, the second character is any character, and the third character is space. Okay, so that's a match, and this is a match, right? So O, any character, space, O, any character, space. Okay. So also we can specify which characters we are fine with, right? So we look for the string composed of 4 characters. The first character is B. The second character can be any of, either it will be E, O, or R, and then AT. Given the sentence, we have 3 matches. That's a match because B is here, then E is among those, AT. The same here, R is among those, and O is among the characters we are fine with. Okay. So we can say the characters we don't want to see as the second characters in our example, right? So we are fine as a second character in the string we are looking for besides E and O. Okay, that will be a match because R is not among those. Okay, so some examples. So given the file which you do have in your W1 files directory, please use the grep and let's look for this regular expression where you saw it already. So it's composed of 4 characters. The first character is B. The second character is either E, either O, or R, and AT. Okay, the second regular expression, we will look kind of for the same thing, except that the second character might be any character. That's why we're using the dot. The dot stands for any character. Also, we can say that as a second character, we are fine with any character besides those, and should be AT. And here we'll look just for the regular expression composed of 2 characters. The first character is B. The second character could be anyone, any character besides those 2. Okay, so any question before we start? Okay, so let's do it one by one. Okay, so we need a file which is called regex.txt. Do you want to look inside the file to see what is there? Okay, so there is beet, bread, boat, bat, and banana. Okay, 5 words. Every word on a single line. Okay, so we do grep, all the time double quotes, B, E, O, R, A, T, and regex, and the file name. Okay, so we see, I guess, what we expect to see, beet, bread, and boat. Let's change it, and then I think I will encourage you not to type all of, like every time or again from scratch. Try to use the previous command. I guess this is a good habit to have. Press up key, get access to your previous command, go to the place what you need to modify and modify that. It's not a... Okay, So it will be b dot at, and that will stands for any character. I guess the results will be the same. We'll not see the changes. Okay, so let's use again the previous command, this one, and let's put cap here, which will stand for that we don't want to see those characters. Okay, so not a single line matches the regular expression. So let's try modify it slightly, where we'll remove this at. So now we'll be looking at the regular expression composed of two characters. The first character is b, the second character can be any character besides those. Okay, and then the bat and banana will be a match, because b, a is not among those, so we are fine. The same here, b, a is not among those. Okay, so any questions? Okay, so more characters, or like more, I guess, notations, just to kind of make sure that everybody is on the same page, and a couple of new notations as well. So if we look at this regular expression right here, this means that we'll match any of those characters, A, E, I, O, and U, right? So what about this one? Probably it could occur if somebody misspell your last name or first name and put it as a first character, not the capital, but kind of lowercase letter. So here, by this regular expression, we will just match two words. The first word is with the lowercase and the second one with the uppercase. Also, we can save the time. So instead of typing all those characters, we can provide the range, assuming those are sorted, and and then there is no, like they are in the increasing order. There is no digit missing, right? So we provide the range. So we want to say that by this notation, we will say all the numbers from all the digits from 1 to 9. So the same here. So if it's alphabetical, you're fine with the range from the alphabet, just say it, from A to E. Also, we can combine, we can provide the range from the alphabet as well as the range from the digits, right? So we say the range from the alphabet from A to E and from 1 to 9. But be careful with that, just because if you say this notation, then it has nothing to do with the range. It will be 4 different characters, right? So always be careful with that. Okay. So let's see some more notations, where to refer to all the alphabetic characters, you can say like this, right? Lowercase from A to Z, uppercase from A to Z. That's all, right? Alternatively, we'll be using this notation. We'll say alpha, standing for alphabetical characters. So in terms of the digits, all the digits we know are from 0 to 9. So why not say that, right? 0 to 9, meaning any digit. Or you can say this, but I think it's longer. So we'll be stick with this notation when we refer to any digit. If you want to combine both, you want to say all the alphabetical character, which is here, and then all the digits, which is here, which is referred as alphanumerical characters. We'll say alnum, alphanumerical characters. So we'll be using this 3 notation. Alpha for alphabetical characters, 0 to 9 for any digits, and alphanumerical for any the characters, alphabetical characters and the number and the digits. Okay. Also, you can specify where your regular expression needs to be in the line. Do you want it to be in the beginning of the line, or you want it to be in the end of the line? So if you want it to be in the beginning of the line, you say cap, just like this, or you say $, which will mean the end of the line. So for example, so if you say for this regular expression you want to see it in the beginning of the line, that will be the only match you will find, because this is the only word which is located at the beginning of the line, right? Not this one or this one. If you want to say that you want that regular expression to be located in the end of the line, you just say dollar here, and here you go, right? That's the only match. Okay, so any questions? Okay, so I have a question for you. So what do you think this means? So you basically want to say that the word, whatever, a string, this particular string, which is the word, you want to be located simultaneously in the beginning and end of the line. What does it mean? That I'm sorry? Yeah, exactly. You look for the string which exactly composed of that particular word. Nothing else is there. Yeah. What about this one? So you want to see the beginning of the line, end of the line, nothing in between. What is that? Empty line, right? Yep. Empty line. So if you want to find all empty lines from your file, use this regular expression. Right? Okay, so let's move on. Okay, so let's get some practice. So we'll get the file which is regex2.txt. So there is a bunch of some characters and the numbers, like in random order. So there is no really the words or sentences. And we'll be looking for the regular expression, which is composed of two characters here. The first character is either capital A or lowercase a and 1. Okay. Also, we can say that that particular regular expression needs to be placed in the beginning of the line. If it's not in the beginning of the line, we don't want to see it. Then we use this notation, cap, right, to specify that we want to see it in the beginning of the line. Okay, so let's make it more complicated, where we want to say that we are looking for the regular expression, which is composed of two characters, right? The first character is A uppercase or A lowercase, and the second character is any digit you can imagine. Okay, and then it needs to be necessarily in the end of the line, right? That's what dollar stands for. Okay, or we can say as simple as let's see any line which has at least one digit. That will be it, right? If the line will contain the digit, it will pop up using this command. Also, we can check the lines which have alphanumerical characters, all known, or the alphabetical characters, just like this. Okay, so any questions before we try? Okay, so let's see the file. I guess it's good to know what the file you make a search, so you will have a better idea of the results. So regex2.txt. Okay, that's the file. So bunch of A's, B's, the different order. That's the file. You can look by yourself as well, right? That's the file. Okay, so let's do the first grep, where we say grep A. The first character is A uppercase, A or A lowercase, 1, and the name regex2.txt. Okay. So that will be a match. Looks like it's right. Yeah, so there is A1, that's a match. A capital A1, that's a match, right? So if we want to say that should be necessarily in the beginning of the line, I think both of them are, right? So it will not change. Just because those two matches are already in the beginning of the line. So we'll see kind of the same result. Let's change it a little bit. So I encourage you to change again. So I encourage you to use the previously entered command and just modify those instead of typing from scratch. So 0 to 9, right? So we're looking for the regular expression composed of two characters. The first character is AA and the digit. Okay. Okay, we see something more. Just because this is a match, or this is a match, at both of them, right? So it's A and the digit, that's a match, right? Or like A and the digit, that's another match. So two matches. Okay, that's why the line was printed. Okay, so what about we look only for all the lines which contain at least one digit? Okay, so we'll have many of those. And then if you look carefully for those, all of them will have at least one digit. So it looks like it does work. So if we want to say alphanumerical character here, please do so. Num. Alphanumerical character means both alphabetical characters and the numbers. And then as a result, so basically we'll see all the lines. Because all the lines will have at least a digit and at least alphabetical character. Okay, so instead of alphanumerical, let's do just alphabetical character. Okay. And then you will see the same results for a reason that I don't have a line which is entirely composed of the digit, right? Which will be not picked up. All the lines at least contains alphabetical character. Okay, so this gives you the idea kind of how you can do it. So any questions? Okay, so let's move on. Okay, so let's see, I guess, the most confusing part, at least today. So which is the asterisk or the star, what you call it. So let me read just the definition, because not seeing the example is impossible to understand, I guess. So so it will match the 0 or more occurrences of the preceding character. This is what it is. So let's see the example. So, and then the important thing is that we say a star or a asterisk. The asterisk will belong to the previous character, right? So in this case, star belongs to a. So we should read it like this. This is the regular expression composed of 3 characters. The first character is y, then there is a star y. So in other words, the first character is y, then a star, meaning 0 or more occurrences of a, and the y. Okay, so if you have this sentence, that will be a match. Y, 0 or more occurrences of a. That sounds right. Many occurrences of a, I do see, and y. That's a match. That here is a match as well. I'm sorry?
It would give you just YY.
You mean here?
Yeah.
I mean, the thing is like so we think here, so okay, so we're looking for the match. So that will be a match just because there is 0 more occurrences of a. So I'm not sure if I understand the question.
But so the string, just YY would also be a match then.
Right, exactly, yeah, but I don't want to jump, kind of. That's what we talk here. We'll be talking here, right? I want to try to take it step by step, so that will be done. So that's right, yeah, YY will also work. Okay, so here, O, A star, O, right? And then that is a match. And the reason this is a match, because there is 0 occurrences of A, right? 0 means nothing, and then you see nothing. Can you see nothing in between O's, right? It's there. Okay. So it might be confusing in the beginning, but then as we see more examples, I guess it should make sense. Okay, so more notations. So asterisk, which we just saw, so 0 more occurrences of something. Then I guess here we should say about the optional element, right? So what's mean optional element, that means 0 or 1 occurrences. Either the element is there or not, right? That's where we'll use the question mark. If I think plus will make more sense. So it will be 1 or more occurrences of some element. So element should be there necessarily, right? So then we can say how many times we want element to occur. Then we put in the curly braces, number of times. Then we can even provide the range. We want element to occur we are fine with element to occur between x and y times. We don't necessarily need to give an upper bound. We just say it needs to occur at least x number of times. Or there's another notation where we can say we are fine with this element, R1, and with the element R2. And for all of those, we need to use the advanced settings, which we need to use the grep minus E, capital E. Okay, so I guess I should have some examples. No, another slide before the examples. Okay, so we will have special notations for space, which will be what is backslash space, I'm sorry, slash space, then the tab. Then if you want many spaces, for example, you just say plus, right? And plus will mean one or more spaces. Or if you want adjacent, if you want not using the plus, you can specify how many adjacent spaces or adjacent tabs do you want. Just like that. Okay, so let's start with the this bar where we were saying that we are fine with this element A1 and B1, and then for that we use minus C. So we want to find the element in the text if the line contains element B1 or the string A1 and or the string B1. We want to print it, right? Okay, so if you look carefully for that, you can always find alternative way to do it. And the alternative way to be like this. And then let's try to see how does it relate. Because if you look carefully on this regular expression, you might notice that here the second element will be 1 all the time. Or like the second character. The second character will be in both cases. Here and here will be 1 all the time. And it will be A or B. Okay, so why not use our regular notations, which we are used to, and just say, as the first character, I want to see either A or B, and the second character needs to be 1. So it's exactly equivalent. Okay. Okay, so let's run those two commands and see how it works. So again, for the first one, don't forget to use the minus E option. So it's A1, B1, so it should be bar over the pipe, B1, and then the name of the file. Okay, so this line contains actually both. So, and this one contains B1, right here. So that's why both were displayed. Okay, so let's write the alternative way where you will say grep as the first character AB, as the second character 1, and then Regex 2. Okay, so should we give you exactly equivalent solution? Okay, so any questions so far? Okay, and then that comes to our question how we can distinguish between the chromosome 2 and 21. And then if you think about that after the string chromosome 2, there is a space, and then the second line, and the chromosome 2, there is chromosome 2, 1, right? So then we can we'll be able to distinguish. We just need to say that after the string chromosome 2, CHR2, should be a space. So this way we'll not pick up the chromosome 21. Okay, so I guess let's try and see if it works. So we do grep chromosome 2 space file name and save it. You can save it to a different file or you can save it to the same file, right? That's kind of the every time you need to think of, right? So at this point, I know that there is old version of this. And the question, do I need it? I say I don't. So I will overwrite. Okay, so let's see how many lines there are in the file we just created. So there are 1,000 lines. Okay, sounds better because it was 2,000 before. So looks like things are working. But let's make sure. Let's do head of the file. Okay, chromosome 2. Let's do tail of the file. And then we see only chromosome 2. Okay, let's try it. Do we have guarantee that there is no chromosome 21 in between? We don't. Why don't we just grep for chromosome 21? On the file name. Right? We can explicitly ask, do we see any lines with chromosome 21? We don't expect to see those, right? Just to make sure. Because we look at the beginning of the file, in the end of the file, but no guarantee in between. Maybe something's going on. Okay, we see nothing, which is good news, right? So using the space, you can really kind of trick the things. We'll see a couple of ways to distinguish, to kind of deal with this problem, to distinguish between the chromosome 2 and 21 as we move on in the class.
So if you want it to be like either a space or a period form?
Yeah, I think you try it? Yeah, I think it's like, yeah, you can use those notations, like put, so what will be there? Space, yeah, and then backslash, yep, and then the period here. Yep. This one? Yeah, okay. Did you run it already?
Oh, no,
I think you just put the period there. Space. I mean, yeah, you can have as many characters as you want. A here, B here, period, dot, like everything. Yes, any other questions? Okay, so again, so we'll see other solutions of this chromosome 221, but that's one of them. Okay, so also we can, when we're dealing with the star or the asterisk, we can, usually we saw the example where it refers to a single character, but we can kind of refer it to the expression. Okay, so if we say a star, that means 0 more occurrences of A, as you know, right? If we say ABC, star refers to C, meaning that that will be the string which will match AB, right? 0 occurrences of C, ABC, 1 occurrences of C, ABCC, 2 occurrences, and so on. Just because it refers to the previous character. But we can say that the star, we can make the star to refer to the whole expression. Then we just need to put the expression in the parentheses. So in this case, a star will refer to the expression ABC. So we are talking about matching the nothing, right? 0 occurrences of ABC, or like 1 occurrences of ABC, ABC, or 2 occurrences of ABC, 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 and so on, right? Also, we can specify, as we saw on the previous slides, we can specify the range, how many times we want that expression to occur. And again, if we're in the parentheses, that thing will refer to the whole expression in the parentheses. So here it will be matching 2 strings. The first string composed of 2 twice, ABC twice, and ABC 3 times. Okay. No, you can put another like D, right? That's fine. Yeah, it doesn't need to be in the end of the regular expression. Okay. Any other questions? Okay, so some examples. So the first one, you remember that Regex 2, that TXT where you have a bunch of ABCs and numbers and so on in the random order. So we're looking for A plus. As we use the plus, we don't forget to use the minus E option. So plus means at least one occurrence of A. So then you can say A, I want to see A to occur 3 times. But the alternative way, just say A, right? That will be exactly the same thing. Or you can say, I want to see A to occur between 2 and 3 times. All right? So it will be matching A or A. Or you can say that I want A to occur just twice. Or other words, that will be AA, right here, AA. So there is no space here, even though it looks like, but there is no space. So then, like this expression ABC to occur 0 more times, right? So you put the parentheses, that's why the star will refer to the whole expression in the parentheses. You can say ABC plus, which will be at least 1 occurrences of ABC. You can specify exactly how many times you want ABC to occur. Precise time, twice. Other words, that's exactly the expression ABC, right here. ABC to occur twice, that's ABC. Okay, so that's kind of easy stuff. So let's jump into something more sophisticated. So for example, this one, where you say alpha. So this is the alphabetical character right here. So you want to say that you want alphabetical character to occur 3 times. Right? So in other words, you're looking for 3 consecutive alphabetical characters in the text. Right? Okay, so also you can say this. You can say, I want to see the alphabetical character right here, and I want to see a digit to occur twice. So the example of matching will be A 2, right? Or A 3, or B 1, right? So alphabetical characters and 2 consecutive digits. Okay. Let's modify it, and the key is here, this parenthesis. That will change everything. Right? We put the parenthesis right here, and suddenly the 2 will refer to the whole expression in the parenthesis. So now we are talking about the alphabetical character digit to occur twice. So an example of that will be A1, B1, A2, D9, right? That's the structure. Okay, and the very simple in the end, which will be alphabetical character, right here, digit, space, and A. Why not? Okay, so any questions before we try? Okay, so let's start with the simple stuff where we do grep. Don't forget minus E, capital E, so A plus. So at least 1 occurrence of A. Okay, so that's what we'll get. So if you look carefully on the lines that were displayed by grep, all of them will contain at least 1 A. Okay, so if you want A to occur exactly 3 times, that's how we should write it. And then that's what you got, right? A to occur 3 times. So we want to provide the range. I want to say I want A to occur between 2 and 3 times. You get both. You get A to occur 3 times here, and you got A to occur twice right here. So if I want again exactly say A to occur twice, you just need to change it here. And then you will see the result. So that might be a little bit confusing, but then you should kind of think of that. If you're asking A to occur twice, it's kind of substring of the A occurring 3 times, right? So review it something like this. So A. So to occur 3 times, and then substring of that is A to occur twice, right?
If you wanted to occur like between 2 to 4 times, can you just put like 2 to 4 in the brackets?
Yes, yeah. Yeah, you can provide any range. Okay, so twice. So now we say ABC to occur 0 more times. So basically we'll match everything, right? You will see every single line just because we put the star, right? 0, kind of nothing matches everything. So let's put plus, which will be more meaningful result, right? So ABC to occur at least once. So if we do so, that's the lines we'll see. And both of them, we see ABC to occur once, right? Right here, and then right here. Okay, if we want to say ABC to occur twice, we don't have it. Just because here it's, this is the capital A. So maybe you want to add I option here, which will be make it case insensitive, I guess, right? And then that will not care about is it lowercase or uppercase, right? So I put the I right here, which will make it case insensitive. Okay, so I guess it was easy. So let's see something with more kind of general things. So where will be grep minus E. So we say alphanumerical character to occur 3 times. The file name. So in other words, you're looking for 3 consecutive alphabetical characters. Do we have any? Yeah, we have plenty. So I guess this is a match, this is a match, this is a match starting from the second, because this is capital. No, we don't care about capital, yeah. So I think 3, that was a match, and this is a match, right? That's why they were displayed. Okay, so let's change it slightly, where we say the first character should be alphabetical, the second character should be a digit, and we want a digit to occur twice. Yeah, we don't. Yeah, I think we don't have any. Think like that in the text. So let's put the parentheses right here. Where the meaning will be completely different. We say we want the alphabetical character, a digit, and the whole thing to occur twice. Okay. So this is what we're looking for. So the B1, A2, that's a match. Right, so you have an alphabetical character, a digit to occur twice. Okay. Okay, and the very last thing where we look for alphabetical character again. A digit, space, and A. Okay, that's exactly the same. So here, alphabetical character, a digit, space, and A. So this is exactly the match. Okay, so any questions here? Okay, so then if you don't have a question, I have a question for you. So can you tell me what this line does? So I'm sure you will be able to read it through, even though it does look long, but there is no unknown characters here. All the characters of the regular expression, they are kind of covered, you know them. Just try to read through the line and try to see what it does. So, any ideas? Okay, so let's try to read it together. So that's a digit, right here, a digit to occur 3 times, right? A digit to occur 3 times, right? Then we have a choice of space. This is just notation for the dash. to occur 0 or 1 time. In other words, this is optional. So you might have space, you might have dash, or you might have nothing. Okay? Again, another 3 digits. Again, an optional thing. Space, dash, or nothing, right? And the 4 digits. Is that? So what we're looking for? Yeah, exactly. Yeah, because you can write, so basically you have a huge text file and you expect people to write in the very different format, the cell phone numbers or the social security numbers, and then you want to extract all of them, no matter how they wrote it. Yeah, so if you write all the thing without, like separation, without spaces, you're fine. If you wrote one space, then didn't wrote the space, you're still fine. We'll catch it, right, using this regular expression. Okay. So this is kind of what we're looking for. So, you know, like regular expression to extract certain information, no matter of the format, to kind of deal with different if-she's of the format and so on. Okay, so the last part for today, that will be the seed. We call it stream editor. So any question before about the grep, by the way, because I think we are done with the grep for today. Okay, so we'll be talking about the seed, stream editor. So this is called non-interactive text editor. So you edit the file without opening. The reason is that sometimes the files are huge, again, million of lines, you just can't open them. There is no way you can. So what you do, you use the stream editor, which will edit the file and will not open it. Yeah, so that's the motivation. And as well as this is a super nice way, just because you can do multiple edits in a single line, right? You want to substitute this word by this word, do something else, and all in the single line. Okay, I think I have it here. So this is how the general syntax will look like. So you say seed, then you say the options, the command, and the file you want to edit. Okay, so let's start with something very simple when we want to substitute one word by another one. So this is how the syntax will look like. So you say seed, you say s, which stands for substitute. You say the old word and the new word. So you will substitute the old one by the new one. And the file you want to edit right here. Okay, so what about we did a typo in the sentence which is to be or not to be. We wrote B with double E. We want to fix it. So this is how we will do it. Old word, right? B with double E. B with double E and B with a single E. Okay, and file which we want to edit. So by running this command, you will see the new version of the file on the screen. First thing you might notice that only one typo was fixed. The first one. The second was not. And the reason is just because we didn't use the G option. So G option stands for the global replacement, and meaning that in every line we'll go all the way to the end of that line and we'll fix all the typos, or we'll perform all the changes, all the substitutions. So by running this with the G, you will be able to fix all the typos. So one thing you might notice that, actually maybe let's run it and then you will notice by yourself. Okay, let's run the command. You have the file already, you can see it. It's called file seed, do less, file seed. Okay. Okay, let's see. Maybe call it something else. Seed file, yeah. That's right. Okay, that's the file. You see the... No, that's another one. I'm sorry. I should have it. Maybe I don't run it. Okay, I think maybe I don't have it. So we'll have plenty of examples. Okay, so one thing I wanted to point that here, as you run the command, you see the new version the new version of the file on the screen. And that's the thing, you don't edit the original file, kind of, right? You don't touch the original file, instead you're getting the new version on the screen. So what you can do, you can save that version to a separate file. And then we'll show exactly how it works. But just keep in mind that you never edit the original file. You're getting the new version on the screen, or you can redirect it to a file. And then we will be kind of discussing it more as we go through. Okay, so one more, before we get example, one more thing is you can put the, for example, the parentheses around the match text. So you match the text in the file and you can modify it. You can put the parentheses around, maybe you can put something else around and stuff like this. And the way to do it, so you say as usually, then you say the pattern, the text you want to match, and then the ampersand here will refer to that text. And you can kind of modify it to put the parentheses around or anything else around. And then we'll see an example of that in a second. Okay, so it's called to be. That's my bad. So we do have that file. It's just called to be.txt. Okay, so we do have that file, to be.txt, where there is a type. So let's try first to run without the G option, and then you will see that only one typo was fixed right here, right? And the second one is not. As you add the G option, which is right here, then both typos will be fixed. Okay, so let's start from that simple example, which will give you the idea how to use the seed. So we do seed. Okay, let's look at the file first. To be. Okay. I think something happened. There is no file, right? Okay, so let's type, I guess. Let's create the file. Because I thought I put it there, maybe something happened. So let's create that file. That will be another opportunity to practice how to use the VI. So create the file to be.txt and put the sentence to be double. Make sure to make the typo on not to be. Right? That's the sentence. To save the file, press escape, shift semicolon, give it the column, WQ, right? So you got your file. So now, as you have your file, let's run the seed. Seed as B with W, which is the word, the old word you want to substitute by B with single E and then file name. Okay, so this is what you need to run. Yeah, that's what I was trying to say, that you never modify the original file. Instead, you're getting the new version on the screen, which you can save to a different file. And then in a second, we'll be discussing how to replace the original file. You just redirect it, just like this, to a file and give a name. Okay, so but let's get to that. Okay, so this is the seed where you replace B with W with the B with the single E, right? And then you never modify the original file. You see the new version on your screen. And as you can see, we didn't use the G option. That's why we see the second type and not to be fixed. If we want to fix it, we need to add G, which will mean that the seed will go all the way in every line to the very end, fixing all the typos, making all the substitution. Okay, so that's about right. Yeah, so we got the sentence to be fixed. So now we come to the question that, yes, we got the new version, but what we're gonna do? So I suggest you to save it and give a new name, like to be new, for example, .txt, right? So you will redirect the output of the seed into the file which you call to be new.txt. The original file will be preserved, you never touch it, kind of. And you will get the new version to be saved in the file which we'll just create. Okay, we want to check it out, how the file looks like. do less, to be, new. Okay, the file looks nice. All the titles were fixed. Okay, so but what about you really want to edit the file? You really want to change the original file. So what you do move to be new to be the txt, right? So what this command does, it will replace the original, it will replace the original file with the new file you just created, right? So if you have the system set it up, the security, you should be asked, do you really want to override it? You're sure you don't need the original file? You want the new version of it? Go for it. Say yes. And then what will happen? Let's check the file which is called to be. First of all, we don't have the to be new anymore. All we have this is to be, which is the modified version. Right? This is how it looks. So that's the idea. So it kind of requires additional step if you really want to modify the original file, rather than creating the new version of it. Okay, so any questions here? Okay, so if no questions, let's see another example. So we do have the sentence 7th score. Let's see the sentence, because it's always nice to know the file. So the file should be file underscore seed.txt. Let's open it. Seed underscore seed underscore file.txt. So the file is called 4 score and 7 years ago. That's the file, or that's the sentence which is in the file. We want to make some edits to the file. So the first edit we want to do, we want to modify, we want to substitute 7 by 9 and do it globally, meaning that all the way to the end of every line. So every time we see the word 7, we'll substitute it by 9. How about that? Then I want to do another round of edits. And then that's why I do the pipe right here. And then as kind of the file which was edited this way will serve as the input for the second round of edits, and so on. You may have as many rounds of edit as you like. So I will substitute 9 by 2. And again, do it globally. Okay, so we'll see in a second how it works. So also we don't necessarily need to substitute the whole word, but we can substitute the digits, we can substitute the single letters, as here. We want to substitute A by O, so why not? Take the file, substitute every time we see A, will be substituted by O. Okay. Also, we can use the regular expressions in the seed, not only in the grep. So those regular expressions are pretty universal and can be used among many tools. So here we'll say we use the regular expression to specify that we want to substitute AND only in the case if it's located in the beginning of the line. If not, we'll not substitute it, right? So every AND located in the beginning of the line will be substituted by OR for this file. Okay, also we can substitute the word which is composed of 1, 2, 3, 4, 5. 5 characters. The first character is S. Any other characters can be any characters. And substitute by all x's. X, 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 X. 5 x's. Okay. So the dot means any character. So basically you have 4 characters, can be any character. So here as well, we want to say go and substitute. We want to substitute a go, which needs to be located in the end of the line, which is the dollar sign stands for, and substitute it by exclamation sign. Okay. So any questions here? Okay, so let's start with the first one, where we say we want to substitute S, right? 7 by 9. Okay. By 9. do it globally, and provide the file. Okay, should be seed file. Okay, press enter. Let's see the first round. What will happen? So before it was 4 score and 7 years ago, now it's 4 score and 9 years ago. Okay, makes sense, right? So it did work. So we want to do a second round. And then that means we'll put the pipe, then we do seed as 9 will be substituted by 2. Okay, do it globally. So after this round, 9 will be substituted by 2. Only here. Okay, so this way you can make as many edits as you like using the pipeline, right? Okay. So here we want to substitute A by O in the same file. So the O, we can do it globally and give it the same file, seed underscore file. Okay, so every A was substituted by O. Okay. If you want to imply regular expressions, you need to put the cap right here, say and or. So we want to substitute and by or, but only in the case if and is located in the beginning of the line. So nothing will change, as you see, just because we don't have any and which is located in the beginning of the line, right? That's why nothing was substituted.
You can send it directly to overwrite the seed file. Not
I'm sorry?
if you do seed and this, but overwriting seed file.
Oh, the same one. You mean, okay, let me, this what you mean?
And then over, yeah,
Like this.
yeah.
You can't. You should not. Because you will empty that file. That you will remove that file. No, I mean the reason is just because it's reading the file, which is this one, right? Okay. So it's reading this file. So while it's reading, it's also writing to the same file. So it's a conflict. Yeah, so it's a conflict. Yeah. Yeah, yeah. So it's a conflict, and yeah, so eventually it will be empty. Yeah. So if you do that, you're losing the file. And you might not get the warning for that. So it's, I guess, one of the most... okay. So that's the most, I guess that's the thing which I don't have the security for. So that's one of the things you might lose the file. So it's a great point. Yeah, so through your experience, you got this point. Okay. So never do it. Try not to do it. Okay, so we don't have and to be located at the beginning of the line. So what we do, let's remove this let's remove this requirement to and to be located in the beginning of the line. Let's just run it, and then it will work. Okay. So we substituted and by or. Okay, so another regular expression we want to try will be s. Substitute for s and 4 characters. 1, 2, 3, 4. Substituted by all x's. 1, 2, 3, 4, 5. Okay, let's try. I guess the score we substituted was expectable. 7 was expectable, but here might be not as expected. Because before it was 4 scores and 7 years ago. 7 years. So here was S, and there was a space and a go. So space is any characters as well, right? Okay, and the last one here will be a go. A go in the end of the line to be substituted by exclamation sign. And do it globally. Okay. Actually, globally doesn't matter here, just because we are looking at it if you want to be as precise. So you don't need globally here, just because this is already located in the end of the line, right? Okay, anyways, so this is how it will look like. So if you want something nicer, you want to remove the space, right here. So let's think how to do it. How about that? Okay, so we're not just substituting a go, but we know that in front of the go there is also the space. So we want to substitute that as well, just to look nice, I guess, right? Not to have the space right here as we do it here. Okay, so the thing about the space. So I use the special notations for the space, but really normal space will work as well, right? Okay, so it comes to the thing that for the seed, you don't need a special character for space, as you need it for the grep. So I guess you have two strategies. Either you remember that for grep you need special character, for seed you don't, or you just use special character all over. So it's up to you how you would remember that. Okay? Okay, so the last part we look at this Regex 2. Again, bunch of A and B's in random order. And then we'll substitute either 1 or 2. This is what this regular notation stands for. Either 1 or 2, we'll substitute by 3 and do it globally. Also, we can substitute any alphabetical characters by capital B. Why not? That should work. Also, the example we discussed, this is where we want to edit the text that we match. So we will match any two preceding alphanumerical characters, and we'll put the parentheses around them. And then if we do so, we need to use -e option here. Just because we use this ampersand, which stands for the match text, then that's the only case in the seed which we are covering when we will where we will need to use the -e option. Okay, so let's start with the first one. So we do seed. So we'll substitute either 1 or 2 by 3 and do it globally. Alright, so anytime we see 1 or 2, we will substitute it by 3. That's what we're trying to do. Okay, so I guess here this is where you can see the changes. It was before 2 and 1, so you don't see those anymore. All 3s, digit 3 is all over here. Okay, so the next one is to substitute any alphabetical characters alpha by B and do it globally. So every time we see alphabetical character, we will substitute it by the capital B. Okay, so looks right, it works, right? So we don't see any other alphabetical character than B, meaning that probably everything was substituted, as you can see. Okay, so the last one will be seed -e, because we're using this ampersand for the matched text. We say S. So every time we see 2 consecutive alphanumerical characters, alnum. Okay, alnum twice. Okay, we say ampersand, which refer to the text which we match, and then we can put the parentheses around or anything you wish around. Okay, and the name of the file. Okay, so we match the text and we put something around. In this case, we just put the parentheses. Okay, let's see how it works. Okay, so anytime it sees 2 alphanumerical characters, it will put parentheses around. And I guess it goes from the left to right. That's why I put here, but not here, right? Okay, so you don't necessarily need to put the parentheses. You can put anything you can imagine, maybe a couple of zeros, I guess, should work. Yep. Okay, so you can match the text and you can edit it. So any questions here? I think we're almost done. Okay, so the seed also can delete the lines, and then it's as simple as just say the line you want to delete. So you say seed 3D, meaning you want to delete the line number 3, and then the seed will delete for you. The same story. It will not modify the original file, you will get the new version of the file on your screen. If you want to redirect it, you can do so, and then you move and then change the original file if you need to. Also, we can use the regular expression here as well. You want to delete all the lines which contain this, which contains this word, right? So as soon as you see the combination of letters A, W, K, you will delete that line. Or you can delete the last line, just use the dollar sign. So dollar means slightly different things across the tools, right? Remember, for the regular expression, the dollar means end of the line. I guess this is what we cover. So for the seed, the dollar will mean, in this context, it will mean the last line. Okay. So some examples. So we'll want to remove the line number 3 from the file, which is regex2.txt. Also, we want to remove the line right here, which contains the letter A, right? Anytime we see letter A in the line, remove it. Let's be more general, reduce the regular expression. We want to say, let's remove any line with a digit, with at least one digit. You saw the digit in the line, remove it. And this is just removing the very last line of that file. Okay, so any questions? So I guess let's try it. Sure.
And do you delete like just that word, or is just to use the whole line?
I mean, not using the seed, and I don't. I mean, at least, yeah, you can't do it using the seed, and I'm not aware of any tools which can exactly delete particular word, because it's getting pretty.
Just like, is there a way to like replace the word with nothing?
Yes, I guess that's a good point. Let's see. You can use it kind of using the matched text. No. Oh yeah, oh, you're right. Yeah, you can replace the word with nothing. Oh yeah, right. You're right. So that will be something like this. Right? So you will substitute the 1 or 2, or let's say the word. I don't know, what was there? A1 maybe? A1, you will substitute by nothing. So, okay, that was deleted. Okay, yep, that's a great point. Okay, so any other questions? Okay, sorry, let's move. Okay, let's try those commands. So we do seed, removing the line number 3 from the file. I just want to see 4 lines of the file. Okay, so here I think was some line which was deleted. So again, the reason I put the head just to not see the whole file, because my screen is small, so I want to see exactly 4 lines only. The next is you can delete a line which contains the letter A. Okay, so you should not see any lines with A. So let's try to use the regular expression where we will substitute, we will remove any line which has at least one digit. Right, so all of those lines don't have any digit. Okay, and the last one, which is very simple, just remove the very last line, just $D.